Hello, this is Nick Andre, welcoming you to the screencast. In this screencast, we will learn how to create an HTTP and DNS server using Packet Tracer. We will also explore the client-server relationship between web servers and their clients. This particular LAN was created in a previous screencast that demonstrated how to create a local area network that used dynamic host configuration protocol to assign end devices IP addresses. Using this existing topology, that is, this LAN, and the current DHCP server, I will demonstrate how to turn on the web service using Packet Tracer. Remember, a service is a piece of software that runs in the background on a server and responds to the requests made by clients. In this particular case, our server will not only assign end devices IP addresses, but will also host websites. To begin this exercise, I'm going to click on my Server 1 component in my logical workspace. I'm going to click on the Configuration tab, and I'm going to rename this device so it identifies the role of this particular server. In this case, this is a DHCP server, so I'm going to type in DHCP-server. And then I'm going to click the Close button to verify that the server's name was replaced. Like before, I'm going to come down to the lower left corner and click on End Device. And then I'm going to click on the third icon over and choose Server. This time I'm going to come to the right of the switch and drop the web server on. As with the DHCP server, I'm going to rename this server so I can identify what its role is. This is a web server, so I'll type in web-server. And I'll close out of the dialog box. Let's connect this web server to our local area network. Once again, we're going to come down to the lower left corner. This time we're going to click on the lightning bolt. And we're going to choose the auto connect, the first icon over. We're going to click on the web server, and then we're going to click on the switch. Since I'm not very patient right now, I'm just going to click on the fast forward time, and now all my lights are lit up. In order for the server to communicate with the rest of the devices on the network, they have to make sure they agree upon the same terms. Remember, the server is a permanent feature to our network. Unlike the PCs that can come and go and get moved around, the server is going to stay where it's at, so I need to assign it a static address. With the previous example, we were using the 192.168.1.0 address block. The server was 254, the router was 254, the DHCP server was 253, so I'm going to make the web server 252. So by clicking on the web server, I'm going to click on the desktop tab, I'm going to go to the IP configuration, I'm going to put my cursor right above the IP address block, and I'm going to type in 192.168.1.252. I'm going to click on the subnet mask, and it should give me the three 255s followed by a 0. Where it says default gateway, I'm going to replace it with 192.168.1.254. I'm going to close out of my configuration tab, close out of the dialog box, and now if I hover over the web server, a magical box should appear, and my IP address is 192.168.1.252. To activate the web service using Packet Tracer, I'm going to go back to the dialog box that represents the web server by clicking on the web server component. But this time I'm going to click on the Config tab, and over on the left I'm going to click on HTTP. And you'll notice that I have two dots, one for the HTTP being on and the other one for HTTPS, and that's on as well. My file name reads index.html, and according to this little page right here, I have some HTML tags, something just as simple. It reads, "Welcome to Cisco Packet Tracer, opening doors to new opportunities, mine wide open." Just a few little links. If I use this arrow to the right, I will see another page called Hello World. If I keep on paging through these, I have another one called image.html. So my web server has 3 demo pages, if you will. I'm also going to come back over here on this left and click on DHCP, and I'm going to turn this service off. We don't want 2 DHCP servers running in the background on our network. It's just going to cause problems. So I'm just going to save this, make sure that all is good, close out of that. Now that the web service is turned on, I'm going to go to one of my end devices like PC0, and I'm going to open up a web browser. So by clicking on PC0, I can come up to the desktop tab, and I'm going to click on the web browser program in the upper right corner of this dialog box. Now unfortunately, I do not have a DNS server running on my network or have access to a DNS server somewhere else. So when it comes to typing in my URL, I will have to type in 192, the IP address of my server, .168.1.252. Naturally, you would type in like google.com, or in this case demo.com, or whatever. However, since I do not have a DNS service running, I don't have the luxury of doing that, and I have to type in the IP address of the server. If I click go, you'll notice that one web page that I was reading the HTML to you. Welcome to Cisco Packet Tracer, opening doors to new opportunities. And here are the other demo pages. A small web page, that was the hello world. Look at the address bar. You will notice it says http://192.168.1.252/hello world.html. The important thing is you notice the web browser's asking for a web page because it says HTTP. Let me click back, and let me click on the image one. File not found. Unfortunately, I haven't uploaded the picture for the server to display it. No worries. Let's click on the copyrights. And as you can see, I'm just navigating from web page to web page that's already pre-installed on the server. Could I write my own? Absolutely. Sort of beyond the scope of this class. Right now we're just learning how this services work. Speaking about learning how HTTP works, we need to change our mode so we can actually freeze frame the information flowing from the client to the server back to the client. So let me close out of this dialog box, come down here to the right and choose the stopwatch. You'll notice from the last time I left the DHCP service running. That's no longer required, so I'm going to click Edit Filters, remove the check mark next to DHCP, and put a check next to HTTP. Come over here and click on the white workspace, and as you can see, the visible events is HTTP. Let me go back and click on PC1, another end device, click on desktop, go to the web browser, and in the URL type in the address of my server, which is 192.168.1.252, and let me click go. Nothing's happening. Let me minimize this, and let me hit the forward button. Remember, everything's suspended in time. The forward button will allow me to progress, and as you can see, now all of a sudden, in this case, a purple envelope will appear. On your computer it might be a different color, but the point is it's an HTTP message. I can tell by looking up in the event list next to the little info color box to the left it says HTTP. Let me click on this PDU to see what's being displayed. Nothing really at this given moment. If I click on outbound details, I see what Ethernet frame is being used. I also notice that my source IP address of .31, which is PC1 that I'm using to make the request, and the destination of .252, which is the server. I scroll down. I will notice that since this is a web service that's running, that the destination port is 80. Packet tracer will all randomly assign, just like any normal application will, the source port. In this particular case, my web browser's port 1025. This number is randomly assigned and will vary from time to time. Let me scroll down and look at the HTTP message. As you can see, I'm asking for the index page. So I have a GET message. And who am I asking it from? The server. So let me close out of this PDU detail box. And let me hit forward. It's going to arrive at the switch. Now when we did this with DHCP, the message was copied and sent out of all ports. However, now that I understand IP addresses, I can create a unicast conversation between PC1 and the web server. So if all is right and the server is communicating with the switch, the message should just exit out of this port, port 6, and arrive at the web server without bothering anybody else on my network. Let's hit next and see what happens. So forward, and as I said, the message is being sent out of port 6 into the web server. At this given moment, the server is going to be listening to port 80, see that PC1's making a request, and it's going to see if it has anything it can fulfill. We're looking for the index page, so if I click forward, the web server is now passing a message back to PC1. Let's see what's in that message by coming over here to the event list, clicking on the PDU that came from the web server. Now, as you can see, I have some little layer 2 stuff going on, but what I really care about is the outbound details. So let me click on that and scroll down to the bottom. You'll notice that the IP address is switched. Source is now the web server, .252, and it's destined to the client, .31. You can see the source port was flipped. Now it's coming from the web server, so now it's 80, and it's going back to the web browser on port 1025. So let me come back, and now we see that it's no longer a GET message, but rather it's the real HTTP data. In this case, it's the index page. Let me close out of this, click forward, seeing the message go to the PC, and this should be the end of our conversation. That's assuming one thing, that the whole entire web page was able to fit inside this envelope. Sometimes web pages can be pretty big, and that they'll have to send multiple messages from the server to the client. In this case, it's done. I have a green check. If I come over and click on the PC1 button, the web page should actually be displayed. So this is HTTP in a nutshell. The problem I have with my server is that I have to enter in a 192.168.1.252, an IP address. It would be a little bit more professional and easier for my clients if they can just enter in a domain name. So to add a DNS service, I'm going to have to close out of this web browser, close out of the PC1 dialog box, and add another server to my network. Now, it is not too uncommon for one server to hold multiple roles, and that is having my web server, my DHCP server, and my DNS server running on one piece of equipment, especially with modern hardware being as powerful as it is. For this purpose, I'm just going to add another piece of hardware out there because it costs me nothing to do so, and if I have a bigger network, it'll be able to scale up with that larger network. So coming back down to the end device button, I'm going to click on the third button in from the left, choose server, and then I'm going to put it right between the DHCP server and the web server. I'm going to rename the server so it's marked as DNS. Just like you would rename a file, you can click on the label once, hover over it until you get your little I-beam, and then click again. And I'm going to type in DNS-server. Then I'm going to click over in the white area so the name is replaced. I'm going to connect the server to the network, click on the lightning bolt, click on the first icon to do a quick connect, click on DNS server, and then click on the switch. As you can see, I have the orange light and the green light scenario. This time I have 1, 2, 3, 4, 5, 6, 7 components to my network. My network is growing exponentially. Now, with that being said, I added another server, another fixed component to my network, so I must change the IP address so it's static and it belongs to the same logical network as these other devices do. Before I can do that, I'm going to wait for this light to go green. In order to fast forward that, I'm going to go back to real-time mode, click on the fast forward time button, And just like that, the light went green. In the real world, you should wait. It might take a couple of minutes, but eventually if the cable's correct and there's nothing wrong with it, both lights will light up. Let me click on the DNS server. Let me click on the desktop tab. Let me click on IP address. Dot and static. Now where it says IP address, let me click once. Type in 192.168.1.251. Click in the subnet mask. Click on the gateway. 192.168.1.254. Verify that your subnet mask has 3 255s and a 0. Remember, this will now be the DNS server, so when they ask for DNS server information, I will supply it with its own IP address. I know it's self-serving, but I'm basically telling itself, if you want to go out on the web and you're using domain names to do so, look at yourself to find the information. So I typed in 192.168.1.251. Let me close out of that. Let me close out of my dialog box. And I'm just going to test to see if the communication between PC0 and the DNS server is alive. So I'm going to click on PC0, click on the command prompt, and type in ping space 192.168.1.251. If I get 4 replies, then I know that they're able to communicate with each other, and then I can proceed on with the next step, and that is to activate the DNS service. So let me close out of these dialog boxes, and I'm back to the logical workspace. To configure our DNS service, I'm going to click on our DNS server. It's going to open up the DNS server dialog box, and I'm going to click on the config tab. Before I begin configuring DNS, I want to make sure that the HTTP service is turned off. So I come over to the left under services, click on HTTP, put a dot in off, and put a dot under the off for HTTPS. I'm also going to check to see if the DHCP is turned off as well. So I click on DHCP, and I put a dot in off for there. Now I'm going to come over to the left and click on DNS. In order for DNS to function, it has to have a database of IP addresses being mapped to domain names. We call these resource records. In this resource record, I'm going to type in a domain name. For example, I would type in nickandre.com. It is an A record, so it's one of those where the domain name is going to match a particular address. I'm not going to do any kind of alias or chronicle names. So under the address box, I'm just going to type in the name of my web server, which was 192.168, and I meant IP address of my web server. So 192.168.1.252, and then I'm going to click Add. In class, I mentioned something about DNS cache. If this server does not have a particular entry and has to go look at it from somewhere else, when that result comes back, it'll cache those results to minimize future lookups. We're going to ignore that for now. You can see I have one record. nickandre.com is being mapped to 192.168.1.252. Let me close this dialog box and see if this will work. Before I'm able to demonstrate DNS in action, I need to go back and verify that my 3 end devices have the DNS server IP address in their configuration file. So I'm going to hover over any one of these PCs, and I will see that the DNS server is not configured. Since I only have 3 computers on this network, I could probably go back and click on each one of these and manually configure them. But remember, we set up DHCP for a purpose. So I'm going to click on the DHCP server. I'm going to come up to the config tab, come over under the services, and click on DHCP. Where it says DNS server, I'm going to replace all those zeros with the appropriate address. That is 192.168.1.251. I'm going to save this new change. You can see this entry now has a DNS. I'm going to close out of this. And as I said before, there are 3 times where these computers can get the new information. a manual, power down, or an unplug. Let me click on PC 0, go to the command prompt, type in ipconfig space / release and hit enter. Then type in ipconfig space / renew. Give it a second. And now you'll notice that my DNS server information is properly configured to this end device. I'm going to do that for the next two devices. PC1, command prompt, then ipconfig space / release, then ipconfig space / renew. Give it a second, and you should notice that it has a new DNS server. Close out of that, and out of that dialog box, and click on PC2, command prompt, and type in the same commands, ipconfig space / release, then ipconfig space / renew. Give it a second, and we see we have our DNS server configured. That tells the computer that anytime you need to resolve a domain name into an IP address, go see this particular server. Hopefully there's a record. If there isn't, this server would be passed up. Let's see this now in action. Let me click on PC2. Let me come up here and click on the web browser. And in the URL this time I'm going to type in nickandre.com and not the IP address of my service. So nickandre.com, and I'm going to click go. All was well. As it should have done it when I typed in the IP address, it displayed my Cisco packet tracer index file, and if I click on the links like a small page, it works just like before, but this time in the URL it has my domain name. And as before, we should probably change our modes from real-time to simulation so we can learn what exactly goes on. So let me close out of my web browser, close out of the PC2 dialog box, and come down to the lower right corner and click on the stopwatch. And as before, I'm going to edit my filters. I'm going to make sure that the HTTP stays on, but DNS as well. So I'm going to put a check there, click on the workspace. I'm going to go back to PC0 and click on there. I could try it with PC2, but I'm a little gun shy with that. Since I've already put that entry in there, my PC probably has the DNS record cached and it won't bother DNS server. However, since PC0 hasn't gone out to view the website using a domain name, it's not going to be cached. So I click on PC0, then I click on the web browser, and once again, in the URL I'm going to type in nickandre.com, and I'm going to click go. Nothing should happen right now because we are in simulation mode. That means everything's spent in time. In order for me to see things going on, I'm going to have to use the forward capture button. Do you see now that I have a DNS record? The web browser looks at it and says, hey, I can't resolve this name locally, so I need to make a DNS request. Let's take a look at what a DNS request looks like by clicking on the color square in the event list. You can see it's layer 7 protocol in action, DNS. You will also notice that I have a source port of 1025, that's the web browser making this request, but a destination port of 53, that's the DNS server that listens to it. You can see that the IP address is coming from .32, that's PC0, but it's destined to .251, that's my DNS server. Let's look at the outbound details. And as you can see, there'll be a frame, and then we're going to add the IP address, but more importantly, I'm going to come down here to the DNS data. And you can see what I'm trying to do. It's a query. I'm asking the server, hey, do you have this particular record? nickandre.com. If you do, could you respond back with the correct IP address? So let's close out of this and study where the message goes. Let me click forward. And it looks like it didn't find it locally, so it's going to send it to the switch now. So I click forward again. And it should only arrive at one place, and that being DNS server. So let's click forward. There it is. Give it time for it to regenerate that message. Then I'm going to click forward. The DNS server should send something back because it found that record. I know that record's there because I put it there. If it did not find it, that DNS server could have paused the communication process and went out to another DNS server to see if it can find it there. Let's see what the response looks like. So now I'm going to click on the PDU for the event list coming back from the DNS server. Dealing with local delivery, so there's my frame information, but let's look at the outbound stuff. And let's scroll down to the bottom, looking for the DNS response, which they call a DNS answer. nickandre.com is 192.168.1.252, and that's what our web browser will use to find that particular website. Let me close out. Let me hit next or forward. It goes to the PC. At this time it should process that and then do an HTTP request. Got the green check, they're happy. Hit forward, and now you see I have a different color message. Let me scroll down on my event list, and I see this time it's HTTP. Let me click on this box to see what it looks like. And in the destination IP address I have 192.168.1.252. Thank you, DNS, for helping me out getting an address that I normally wouldn't have known by going out there, looking at a database, and responding with the particular part that the web page is looking for. Very transparent, used all the time, and it's always unappreciated. So let's close out of this, and let me click forward. And now it's going to send it to the switch, so click forward again. I'm going to click forward after the switch to pass it to the web server, not the DNS. Click forward again. It's going to pass it back to the switch so then it can make its way to the PC. By the way, if this server exists on another network, instead of going right from the switch to the server, it went from the switch to the router. If I click on PC 0, the web page should be displayed. And that was HTTP and DNS in action. The two usually go hand in hand, and they make life easier for us to navigate from place to place using names and not numbers. Knowing this can be very beneficial when it comes to troubleshooting a network. Sometimes it's not a person's internet connection that's giving an issue, but rather their DNS server being down. Most of us are typing in addresses using names, not numbers. So if I type in google.com and I get a page cannot be found, it's a greater chance that my internet connection is down more so than anything else. But what if it is up? What if I can access certain sites and I can't access that? Then maybe it's the DNS, whether it has to update its records or the server being down. So there are tools like NSLookup that allows you to pinpoint where in the communication process where it fails. In this particular case, the tool will let you know whether DNS is functioning or not. So NS, name server, lookup. So you just type in NS lookup at the command prompt, followed by the name you're looking for. To illustrate this, I'm going to go back to PC 0, click once, click on the command prompt, and type in NS lookup space nickandre.com and hit enter. Remember, I'm in simulation mode. The NS lookup is forcing to use DNS, so you'll see back in my little event list a DNS message appears. I'm going to switch back to real-time mode, go to PC 0 again, and you'll see that NS lookup has resolved the name, told me what server it came from and what the address is for that particular website. If that conflicts with another name server on the internet, then you have to question whether or not your name server is up to date. If it isn't, you can always flush out your DNS cache by using the command ipconfig space /flush DNS. That's for another course, but I'm just letting you know how to use this particular tool for troubleshooting. So let's close out of this, and we're back to our logical workspace after we closed out of the PC 0 dialog box, and we can see that now I have 3 servers, all running their own services. The web server running a web service, that's an HTTPD. The DNS server running named, that's name with the letter D afterwards. And the DHCP server doing its own thing by signing IP addresses to our end devices without our intervention. We updated it, so now it hands out a DNS address as well as our gateway address, so these three end devices are properly configured to handle basic services. In this particular packet tracer demo, we just explored how HTTP and DNS help to make our life easier by connecting web sources and IP addresses together. Take care, and I'll see you in the next screencast.